Welcome back to Mr. G's EV Hangout. This is a place where we share ideas. Rising tide lifts all boats. Tonight we have a super duper CAD episode. Whether you're a beginner or advanced, this is the episode for you. Even though the people that want to know stuff are probably on the call now, but if you're not here live, you watch this episode and you're going to learn a ton because we got a lot of people in the house. I'm going to do a quick roundtable of intros, and then we're going to get started with Thomas. So Thomas is the InfiniteCraftsman. How you doing?
Good, man. Thanks for having me.
All right. And he does a lot of 3D printing for product design. As you know, we also have co-host in the house, Talik, Charge Positive. What's happening?
Hey, hopefully you can hear me with the noise canceling. I'm over here at Jonny's shop, and we're just seeing what projects he's up to. We've got some Model S motors in the works back here, but Jonny, we'll have him talk eventually about what he did with his CAD stuff too.
Nice. And very cool. J5 Jonny, does a lot of CAD work and hands-on fabrication to get his vehicles on the road. We also have Alex from Maverick EV. How you doing?
Yeah, good. How are you doing, guys? Nice to see you again.
All right. And Alex is coming to us live from tomorrow. He's actually in the future in China, and he's going to show us some engineering drawings, like how they're going to fit all the parts in, some CAD work. So that'll be pretty cool. And he's got a lot of product solutions for people. If you're looking to put a Tesla motor in your EV, you don't have to buy a used Tesla motor. You could buy a brand new motor from Maverick EV. So this is a good solution to the market now. Yep. And we also have Kevin DIY Lieberman. He's doing some CAD iterations. Kevin, how you doing?
Good, thanks. Thanks for having me.
All
We're
right.
here at EVLC today. We're installing one of my latest CAD drawings in the bus. I don't want to fix it, but 3 for 3. I've had 3 designs that worked the first time in CAD, 3D printed, and it worked. So,
oh, that's pretty good. That's not like you. What's going on?
Yeah, I don't know. I guess I'm I don't know, erring on the side of caution, and I always make things that are crooked or they're too small or whatever. And I don't know. Maybe I'm learning. I don't know.
Yeah, you're definitely getting better. So that's pretty cool. So in the background is the bus that we worked on last summer, and man, that was a tornado. We had 5 weeks, and we put together this amazing bus. What an incredible situation was that. So some 3D printed parts in there. And what's the 3D printed part? We're going to go through it more later, but just as a preview.
Yeah, so we're using the NACS connector on this bus, and we had it in the gas tank hole, which is nice and sexy, but it's like trying to give an elephant a proctologist exam to try to get your hand in there to go and get it back in the right position. It's so difficult. So instead, I designed and 3D printed this bracket for the NACS adapter that goes right in there. That's going to go sit in the engine compartment instead until we find somebody small enough, brave enough, and with skinny enough arms to go put it right back in the normal gas hole.
All right, so that's awesome, and it's actually better because you open the door and you get to show what's going on. So yeah, let's get into more of that a little later. That's pretty cool. All right, we also got Tyler Joy, and we got Nick C from Arcblast. How you guys doing?
Not bad. Glad to be here.
Doing good. Doing good.
And they've got some cool stuff to show us all about how to get an electric race car to compete with gas cars. You got to do battery swapping. Wham! Pull the battery out, drop it, get the next one, throw it in. And it's not that simple because they're heavy. So we're going to see all the CAD work that goes along with that. And I know that actually Alex has some racing experience as well. So these are like the perfect people on the call. Pretty cool. Night is going to be exciting. All right. Speaking of Night, we got Jonathan Knight. How you doing?
Good. Yeah. I'm excited to show what I've been doing the last week on designing my battery boxes. basically doing that all in CAD, all 3D, trying to figure out how it's going to all fit together. So
nice. Okay, and you're gonna present some of that. We got Justin Homebrew. He's going old school. He's using a butter knife and some scissors to make his projects, but he's gonna learn tonight. How you doing, Justin?
Pretty good. Good to be back.
All right. Also, we got an old school EV guy from back in the day, Frank Dobbs. How you doing?
Frank from EV Riders.
Yeah, you just got to hit unmute. Sorry about that.
Okay, got it now. Yeah. Yeah, I've got no CAD up my sleeve tonight. I just thought I'd tune in and listen.
No problem.
What it's about.
And,
we'll show you some good and bad ways to draw this stuff up and get it printed.
All right.
Yeah, Frank's cool, man. He's been doing a lot of EVs over the last, probably 10 or 15 years. And he's part of the EV Riders Club, originally the Kick Gas Club, from where I actually learned from. So that club's been going a long time. I can't believe it's still around. That's so good. And then obviously, Mr. OG himself, we got Tom Summers in the house.
Hey, everybody. It looks like you got a full house tonight. Really delighted to tune in and listen to everybody's idea on CAD and other stuff.
Nice. And Tom's been a boat engineer and also he's been a driver of innovation and encouragement when it comes to solar, off-grid systems. And also he is a big donator to the EVLC, not just with financial, but also with encouragement and some elbow grease as well. So pretty cool. Thank you, Tom.
And a rolling Brazilian bus.
Oh, right. The yellow bus was his bus, and he decided it had to go on to a higher cause, which is at the EVLC. And we got Jesus in the back there. I see him working it in Kevin's screen.
He's crimping and soldering and splicing back there.
If you've ever seen a sprinkler system and it says Hunter on it, they come from a factory in California where, believe it or not, they actually hire machinists, welders. Like, it's not all outsourced. They do it right there. It's all in-house, which is incredible. And Jesus is one of the hands-on engineers, like a field engineer, that really keeps like the robots and prototypes moving so that you can actually produce a really good American-made product, this Hunter sprinkler system. Like flush out, it's all cool. So thank you, Jesus. And he's donating his time to the EVLC. Very cool. All right, so to get right into it, first up, we're going to dive in. Thomas is coming to us. He's suffering in the 40-degree weather for us, East Coast hardcore. And yeah, man.
I got shorts on. I wear a coat, but I got shorts on. I'm fine.
You got shorts on? Well,
I don't have shorts on. You just can't see. I feel like I've been invited to a secret society meeting. This is great. These guys are brilliant. This is awesome.
It kind of is, I mean, it's funny because like the EV thing is like the slow moving tsunami. And it's just so funny that like it just never ends. Like I don't know when it's going to be that everyone knows about this. For now, it's just whoever knows about it and is interested, gets involved. So the way that Thomas came up was he has a Kubota tractor and he says, "Hey, can I convert this to electric?" Oh, yeah. But you know what? You know something about 3D printing and 3D iteration. And tonight's episode is all about 3D ideas and 3D innovation. So I wanted to see, can you walk us through can you give us an overview of your company and then some of the products you've iterated and how you use 3D printing?
Yeah, sure. I started my website a couple years ago with the mission of creating 200 products in 2 years, 100 products in 2 years. So about one a week. And I hit the ground running with 35 products in the first 35 days. And a lot of it's low-hanging fruit, and they all counted, even the ones that never went to the website. the goal was just no excuses. Even if the product costs too much to make, which means it costs too much to buy, and it doesn't really solve a significant problem, I just wanted to push myself through there. And what I ended up learning through that process was I got in tune with how to identify problems around me and tiny problems. And I've certainly lost a little bit of that because I've lost momentum on that initial goal. But I know I can get back into that mindset when the time is right. So just identifying problems. You're not the only one. No matter what the problem is, you're not the only one, and there's a market for those problems to be solved. And my see, that's a stupid problem. But when you take that thing off its loop, it pokes out at you, and it's just waiting for you to throw something on it. And that's just like a Livestrong bracelet. So
yeah. No, it makes sense because otherwise it's going to sit on the floor.
Yeah.
Or on a shelf.
Well, you put it, you'll hang it on the edge of a shelf and then eventually it gets knocked over and whatever. But this, it's just a more secure way.
So you pick the product you want to talk about because you got so many.
I know. Scroll down. Well, some of them are replications, so that's a Delta lamp. Here, the digital angle finder, I think is designed. It's not a great picture though. No, that's the indicator. That's just for that's for my lathe, and 3D printing is fine because that's about how accurate I get. Yeah, so this is a digital angle finder, and what you're looking at there is a new ring for it. So you basically unscrew it and replace it. And on the bottom left is where you move the magnets to. So now this is to find the angle on your table saw typically. I mean, you can use it for anything, of course. The way it comes, here, I don't have it in front of me, but I have this in front of me. So the way it comes, the magnets are on the side, and you have to raise your blade. Here, I'll use the bottom of my screen. You have to raise your blade enough for the entire thing to hit the side. There you are. With that, you only have to raise your blade about 3/4 of an inch, and you can snag the edge of it. Does that make sense? Did I explain that well?
I think so. Maybe. Oh, it's on a table saw.
Yeah, on a table saw blade. Yeah. So normally you have to put the whole face of that edge on your blade, which means you have to go almost all the way extended, and it's a super annoying thing. But it's barely a problem, right? But woodworkers like to spend money on all kinds of stupid things, so it fits right in the category. And I'm one of them. I'm not blaming them.
Well, it saves time.
Yeah, it saves a lot of time, especially after you get your depth set and then you think to check your angle or whatever. It's super annoying. There's a lot of battery magnets on there, and then something like here, the card shark on your right, the blue and gray thing, right? Like this is just one of those ideas. It's just a card holder. There's nothing special about this. The only thing special about it, and it's not even in this picture because I'm terrible at updating my website, but I bought micro SD card slots that you would solder onto a board. So when you put them in there, they actually click in and click out.
Oh. But
they're not soldered to anything. They're just friction fit into there.
Oh, that's cool.
Yeah, it's just a clever idea. But again, like this is one of those examples of it's kind of too expensive, but that's what it cost me to make it. But the whole idea behind just designing as many things as I can as quickly as I can was to just ignore those factors and just do it. And a few of them sold.
And what about the what do you think your highlight is? The FrogPod?
Yeah, FrogPod. So FrogPod was number 39. And I have one here, of course. I had to go grab one. And it's a camera mount. So go. I should have sent you the Kickstarter page. There's just better photos on there. But that first photo that'll cycle, there's a GIF there.
Oh.
Yeah, that explains it all right there. Literally, that's the whole idea right there. It's just a 3-legged magnetic. It's very hard to get off sometimes. Tripod, essentially. And that was number 39. And that's what slowed me down on my path to 100 ideas. I did a Kickstarter for that, raised about 35 grand, which was incredible. And I printed every single one of them on Prusa Minis, delivered every single one of them. I'm probably around 1,000 FrogPods sold at this point. And yeah, that ruined my goal, but at the same time, it proved what I set out to do, right?
Yeah, it works. I have one. I appreciate it.
On your designs, then you 3D print them and sell them from your house, or you sell people the STL files, or?
So right now I've only done, I'll give out most of the STL files because they're not all novel ideas. They're not all my own creations. They're my iterations. They're my designs of those ideas. So if you ask me for them, I'll just send them to you. The FrogPod's probably the only one I haven't sent out, but you could make it. It's not a very difficult design. More of the, it's sold out right now. I'm out of magnets. I have to buy like 3,000 magnets at a time. It's terrible. So I don't think I answered your question though. I'm sorry, I got distracted by my.
You've iterated on these things, and it is a lot of time, and it's suffering you put into this. So yes, I mean
what's the biggest?
There you go.
You probably had 2 or 3 iterations on some of these things to get it to the point.
No, a lot of them need to fit something, and the iterating to get something to fit, you can usually print just that portion of it. You don't have to print the whole thing to make sure it fits. You can print just like the circle that fits on the rod, right? You don't have to print the whole contraption. With the FrogPod was the first one where I felt like when it was complete, it was actually, I felt like it was actually done. So many of the things I could go back, redesign them 10 more times, even though they're fine, they work, I've sold them, there's no complaints. I feel like I could just keep iterating on those things. This was the first time I felt like I couldn't improve it anymore. It was I'm not going to say it was perfect. That's not what I mean, but it didn't need anything else.
It's perfectly good enough.
It really was. It still is. I mean, 10,000 people told me to put suction cups on it, and I'm like, it took me a while to just be like, no, that's not what it does.
Glow in the dark.
And to like just turn it down. It doesn't have to do everything, but what it does better than anything else, right?
Does it glow in the dark? That's what Frank wants to know.
Is that what you just said? No, not yet. I haven't actually. I don't know if they make. I don't know if they
there
make
is
glow in the dark TPU.
There is something very curious about what you've done. I have 2 observations, kind of questions. Is what is your go-to CAD and 3D printer of choice? And then the other one is, how are you making this awesome, flexible? Like, I tell you what, I've pulled on the FrogPod. It is incredible. So 3 questions. What's your CAD go-to of choice? What's your favorite printer for, I guess, certain situations? And then what would be, how are you getting filament that is flexible?
Yeah, so I use Fusion 360 because it was accessible. I was using SketchUp a long time ago now, and it had its limitations at the time. I have no idea what SketchUp is like now, so use it if you use it. I switched to Fusion 360 because it was free, and they've changed their pricing structures now, but it's still free for some access. And it's very powerful, especially for, I don't want to say especially because I don't have a lot of experience in other things. It's simple enough that you can learn it, whereas like SolidWorks has so much more power, so much more possibilities, but the barrier to entry is way higher, in my opinion. So I do like Fusion for that reason. I forget your second question. The material is
what's your printer? Your printer of choice?
Yeah, so the printer I'm using now is the X1 Carbon by Bambu Labs, and I gotta say, it's almost flawless. Like, it's almost a perfect printer. It just...
Is this it right here?
Yeah, yep. So that hit the scene, and that really revolutionized the consumer 3D printing market. It it came out with so much more tech than anybody else was using, and for the same price point as the other very popular brands. And it just works every time. The few failure print, like literally a few failed prints I've had, several of them were my fault. Like I put the wrong plastic in and I didn't realize it for a while.
It's reasonably priced.
Yeah, even with the AMS, the thing that was on top, it's like $1,600. Yeah, $1,200 without the filament changer. And honestly, you don't need the filament changer, but it's just a nice perk. Yeah, that guy up there. Yeah, very reasonably priced, good size print bed, and I'm telling you, the thing just works. And
how many of these do you have?
Just that one, just one.
You do all your prints on one?
Yeah, I'm not that busy. But it's also, this thing's also like, I want to say, I bought 4 Prusa Minis for the FrogPod thing, and I've since sold 3 of them. But this is faster than all 4 of those combined.
Wow.
Like, I can print more on this than anything else. I make these TV doors for an old TV from the 80s. You know, the doors you click and they drop down and you can change your color and your tint and all that, right? It's for a collector's item that was between Sharp and Nintendo, and there's a Nintendo entertainment system built into the bottom, like a TV VCR, and these 2 doors are always missing on them. And I recreated them and I print them, and one of them took, and it's a high quality print because that's what the community wants. But the one door took over 15 hours to print, and this printer does it in 3, and it's better quality. So, I mean, I can't recommend it any much more than that. It's just.
But I've wrestled with so many terrible printers, and the project becomes getting the printer to work instead of printing what you want.
Yes.
So I'm tired of that. Like, it's got to self-level the bed. It's got to get to the right temperature. I don't want to be updating firmware all the time and this and that, making plates of spaghetti. No, it's got to work every time. So that's why all my cheap ones I've given away now, basically, and I'm saving up for that.
Give them to your enemies.
Yeah, I put an ad up on Craigslist, literally saying, "This thing is a piece of shit. I want it for $100. I'm warning you."
Yeah.
Really, I did not pull punches on that.
Right. Well, I will say I felt the same about my Prusa Minis. Also, very good machines. Very, again, almost flawless, but. No, I mean, the speed difference is incredible. Also, the size difference. I know the MK4 now is probably a much better machine or more comparable machine, but for the same price, it's hard to not recommend Prusa, but Bambu's got them right now.
Okay, so this is pretty cool. I think you've actually cleared up a lot of beginner guidance, because which printer to buy, which software. We're going to get into software a little bit. I'm going to do a little bit of a demo. I have Onshape, which is a SolidWorks clone, but it's online. It's based on the website, but pretty cool that I didn't even know about this printer. So thank you for that. And I've been using the Dremel at the high school, and I bought one for myself, but man, that thing's overpriced. It's like $2,000, and then man, I would rather have this multi the other thing we asked you if you could just go over it quick was the material. How do you get flexible material? What is that?
TPU. It's thermal polyurethane, I think. And it's got like a 95A durometer, so it's flexible, but it's still like quite stiff. It's not, I mean, you felt it, right? It's stiff, but it's flexible. And I might be able to rip this apart, but there's a good chance I can't do it. Like, I'll hurt my hands trying to rip this apart. And this is a centimeter by, like, I don't remember off the top of my head, 2.5 mil, maybe, thick. And these will never fall apart. It's a little overbuilt. I was expecting to hear complaints about the magnets being too strong, actually. I was kind of hoping I would have heard more complaints about the magnets being too strong so I could reduce my cost on those. Yeah, so TPU, it's harder to print. It's definitely harder to print. But like the Bambu Labs printer, the first time I printed, it was flawless and gave me no issues, and it was faster, obviously.
Cool. No, I appreciate that.
So,
Yeah.
Kind of bringing this back to the conversion world, I actually got to check out Eddie's printer setup over at ReVolt, and I just remembered I have some footage from that.
Oh.
So I'll share a couple of clips of that here. We got, everybody see it?
Yeah.
So he's got this is a Creality, as well as he's got an Elegoo Saturn III, but he fabricates these parts for
it's hard.
the conversion, like anything.
Turn off the sound so that we can hear you.
Fortunately, I can't mute the video, but I'll show you. So that on the right there, the white piece, that's a draft piece of a brake switch, and then the thing in the left, on the clear piece on the left, was a cable management for just all the communication cables and with all the AEM stuff. So later on, I'll try to find a clip of where they keep all their AEM cords nice and tidy with 3D printed parts.
Nice. That's awesome.
And I don't think you fully saw it. Yeah, to bring it back to the conversion world. I mean, this is this little bracket I made. Just needed something real quick that would do its purpose. It's just strong enough. It was easy enough to make. And
can you get closer to that?
Yeah. Can you? I can show you the CAD drawing. But that's
a lot better. Wow, that's cool. That just mounts right there for you to use when you want to charge.
Yeah, exactly. And it's it could be better, but I don't know. It's pretty good. So and when we were bringing it back to the conversion world, what I wanted to say also is that some of these materials are good for automotive and harsh environments and UV and heat, and some are not. And different quality. You can have different filaments for doing different purposes. At my job, I had a one that printed in nylon, that was carbon reinforced nylon. Very expensive printer. The material is very expensive, but this stuff you can leave out in the sun, in the heat. You can stand on it. It was so strong, and it's not going to crack. Versus this bracket I made right here is fine. It's good for its purpose, but I know it's not going to last more than a year or so. In a harsh automotive environment, it's going to eventually crack, succumb to UV, everything else, and then
Kevin, I would put some triangles on the side. So you're like this. This is the flex point. Put a triangle on the sides, and that thing won't go anywhere, dude.
Well, I can show you if I can share my screen. I'll show you.
Yeah, do it.
I did actually.
Good transition, Thomas. I appreciate you presenting. That was really good. In the interest of time, we're going to move into the conversion 3D printing area now.
Yeah, thanks, man.
Yeah, man, that was great. Okay, Kev, go for it.
Let's see if I can find how to share this.
Sorry, while he's finding it, I'll share that little clip. While Kevin's finding that.
Going back to Talik at ReVolt Systems. Go ahead,
you can
Talik.
see them there, the orange pieces right there. Those are 3D printed parts for this conversion, and as he's pointing to it right now. In fact, there's Eddie with his printer. So those are keeping tight. You know, all the communication cables with all the AEM systems there.
That's so cool that there's this chance. It's back in the day, you'd have to machine that yourself, or you would have to, iteration's so quick on a 3D printer. It's just unbelievable. What an incredible thing to solve a little problem. I want to take a moment just to introduce someone. I hope I'm saying her name right. Sifa, how you doing?
Hi, I'm good. How are you?
All right, welcome. We haven't met
Thank
before.
you.
I'm glad you're here. Are you into electric vehicles?
What? Sorry, can you repeat that?
We haven't met before. Are you into electric vehicles?
Yeah. So yeah, I've spent like the past like 3 years converting my Mini Cooper to electric. And I'm in college right now, but like I had spring break like 2 weeks ago. So I went home for spring break. Um and drove my car around the block, and it was stressful. Some things happened, but then I had literally I just had to fly back out to college. So yeah, my next step is go back home, test it with coolant, because I wasn't using coolant at the time. There were a lot of problems. My brake system. I have like a clutchless system, and so that has its own problems too. Because I also don't know how to drive stick, but yeah, I'm figuring it out.
Oh,
That was your first drive. Yeah. Congrats.
We applaud
Thank you.
We got your back. We need new people. You seem like a young engineer type person, and I think that this is great that you're doing this. How did you find us?
Richard told me about you. So
cool.
because I was calling him about just like, because I got my Zilla controller from him. So he's basically like my only point of contact with like a real human who is like, a person who is into EVs, because I'm on DIYelectriccar.com, like the forum, but that's literally like my only way of learning. And it's kind of a harsh environment at times, especially for people learning. So Richard's been super helpful, just in, a not condescending voice. So.
Well, I hope you've come to the right place, because that's the whole point. My day job is I'm a high school auto and metal shop teacher, and everyone here is learning. Everyone here is trying to help each other. So you're welcome here, 100%. You got questions, we will try and answer them. And I'm sure if you've gone this far, we probably can learn from you. So welcome.
Yeah, thank you for having me.
Yeah, have you used any 3D printing on your EV conversion to get with the theme of the day?
Wait, can you repeat 3D? What about 3D printing?
Have you used any 3D printing in making your EV conversion?
Sadly, no. The closest I've come was so like for my motor, like my adapter plate between the motor and transmission, because I was using a Warp 9 motor, and there's like CAD files out there, so I like gave the machine shop my CAD files, but I didn't actually manipulate the files. I was actually freshman year, I'm a sophomore now, but freshman year I was a mechanical engineer, and we were learning 3D printing in SolidWorks, but the time that I was working on like the adapter plate was before college, so I didn't know like SolidWorks and all that stuff. So I just like had the CAD file and like got measurements from it, and like I also sent it to the machine shop. But 3D printing definitely would have been helpful for that. Also, for the transmission, I was thinking of ways I could possibly 3D print that, but my transmission, it's so irregular. So I just ended up like tracing, like putting a pizza box on like a cardboard, painting the transmission, putting it on, getting the print, giving it to the machine shop. So sadly did not get any like opportunities to 3D print, but I'm like excited. I don't know, I'm intrigued.
Well, around here we call that cardboard aided drafting, right, Mr. G?
Yes. That's still CAD, that counts. Okay, so let's get over to thank you, Seafer, for being here, and stick around. Also, we're gonna get back to Thomas later, because he's got a Kubota he wants to work on, and so I want everybody to chime in on how he should attack that problem. Okay, so let's get to Kevin, and just right off the bat, I want to say thank you, Kevin, for presenting this. We are in Autodesk Fusion 360, and I'll just say right away, I think you got to have some flying buttresses, like some, you got to think triangles. You're kind of like you're leaning over there, and you got to put down the kickstand. That's my advice for this design, but pretty good so far. Oh, you're muted. Unmute yourself.
Yeah, I can't rebut your flying buttress. So I did fillet this right here to try to make it stronger, knowing that, yes, anything where you have a sharp angle is a place for it to crack. But yes, somebody pulls on this cable, this thing can crack right over.
Yeah.
But you know, I only sort of know like half of what I'm doing in Fusion 360. There's tons and tons of videos on YouTube about how to do it and all this, but you know, I'm in between. Like, I just want to get this done. I don't want to learn everything, and well, I should probably learn better what I'm doing so that I can do this properly instead.
Go ahead, Thomas.
Real quick, what's the hole size and the space between the holes, and then that square size?
Yeah, so the holes are M6. They're 6.5 millimeters, I believe. The spacing was like 80 millimeters or something. I forget. I went by the CAD drawing. I didn't even have the physical NACS connector in hand.
Can you click on those dotted lines, those construction lines, and it'll tell you? Or no?
I'll see. I can go. Yeah, let's go here to this.
I'm going to redraw it while we're talking on here. And
Oh, nice.
Show it to you later.
Okay.
Nice. I was actually thinking the same thing. I'm like, dude, I can't look at this thing. It's going to break.
All right.
There you
hold on.
go. Screenshot that. Zoom in.
Yeah,
Zoom in, Kev. And send that to Tom.
I got it. I took a picture.
You can screenshot.
Oh, beautiful.
All right, cool.
So here, well, this was my very
using
first
heat sensors.
iteration of this, and this hole needs to be a tad wider than it is. What is it set at right now? But I don't know. Like, there's ways to draw things correctly and ways to draw them wrong. And if you draw them correctly and you need to make an adjustment to a measurement, it flows right in there. And if you do it wrong, you make a change to a measurement and the drawing blows up on you and shoots off to infinity.
So let me interpret that a little bit. It has to do with parametrics. So
yes,
it's
and your
almost like,
constraints.
yeah. So like if you gave someone an address, let's say you're going, hey, you need to go to the corner of 60th and Boulevard East. That's a place in New Jersey. And if you say, hey, I want you to go to Boulevard East and 60th, you said it in reverse, but it's the same location. The computer's not going to like that. Not that reverse. I'm just using an analogy. You can't ask it to be somewhere and also ask it again from another angle. It has to have one command. And then the other thing is that when you do one, you should have a mirror. So if you change it and you know you're iterating, you should use a pattern feature. So you only got to change it once and then everything updates. Yeah. Thomas, you want to add anything to that?
Yeah, learning how to think through the parametric nature of it makes iterating so much easier. So like this can be drawn to where you can go back and change any of the dimensions and spit out a new file within seconds, right? Walking you through that right now would take too long, but that really enables you to go back, make that small tweak. So like that center hole that needs to be a little bit bigger, right? You can just go into your parameters. Usually that starts with which one dimension is like the only dimension that even matters, and then build off of that. And instead of putting in values for all of the other dimensions, you simply take that initial value and so like 7 millimeters for those holes. That's probably a critical dimension. And also the spacing of those holes is the critical dimension, right?
Yeah.
And everything kind of relates to that. So even that outer perimeter relates to that. So you can just the 10 millimeters from the center of the hole to the top of the piece.
Right.
That can actually be the diameter of the hole plus a number. And when you change that diameter of the hole until it's the right size, it'll keep expanding that. So you keep retaining that border, for instance. Does that make sense? And totally. That can be extrapolated through the entire piece, though.
Right. Well, it's more like this needs to be based on the center, because if I make it bigger or smaller or whatever, it needs to remain centered on this thing. And that's where So I basically, at some point, trying to fix this thing, it just blew up and went crazy on me. I'm like, it'd be easier to redraw this than try to figure out why. because
no, 100%. Almost everything I do, I end up drawing at least, I end up starting a whole new file, because the first time is just getting your idea out and putting it on there. And then you keep that file to the side, pull all your dimensions off, and redraw it in a much more, in a cleaner way. And then you use less dimensions and use more referencing.
right.
So I want to also add that there's something, I forget exactly what they call it now, but you can change your critical dimensions. You can have it a way to change it, but not even opening up your drawing again. So if you know that, let's say, you know your hole size might change, or you know your center might change, then it'll be called a variable. That's what it's called in Onshape, is a variable. And then you have a list of variables, so you can just change them as you go. So here we go. Tom's going to show
And that
us.
would have been great to make that, like, this angle here should have been that variable. So like, let's try it at 10, 12, and 15 degrees and see which works
exactly
best. And now I did like offset plane to this, and hacking my way through it rather than really understanding. So
100%. Go ahead, Thomas. What do you got? Oh, you're muted for some reason. Oh, Thomas, you're muted. Just unmute yourself. I don't know how.
Oh man, I had some really smart stuff I just said. I guess you missed it. So this holds sockets in my toolbox, right? And the file for it is literally just one. Okay, and as you measure, you can literally measure these with your calipers, put it into a spreadsheet, and import that spreadsheet into Fusion, and it will spit out a file for every single one that you put in your spreadsheet. And these all just puzzle piece together and hold your sockets exactly to the diameter that they are, prints the number on it automatically for you too. But again, I've got, a chain of these that go all the way down to 7 millimeter size. And it's just this file. It's not all of them. So nice. That's what Parametric can do for you, I guess.
Yeah, I've done something similar with 18650 batteries, making my own battery packs to bring it back to conversions. I needed one that was 6P12S or whatever it was. I just gave it that. It designed the file for me, and I printed it out without doing any actual CAD.
Yeah.
Those things
are. I've got a video that's only a minute long that's going to show this in the background. Kevin, if you stop presenting, I'll show it real quick, and then
stop presenting. Okay, very good. That was one of 100 examples of things that I've printed for my EV stuff. So
yeah. So basically what we're talking about is having variables. So here's this little clock radio or whatever. And if you notice, it has these X, that's the variable. And then you can change all that. This is just loading up. But if you start with the grid for the speaker, and okay, it's just loading now. Let's see if you get this to work. Anyway, you add in these variables that extract out. And so you don't have to open up your CAD any longer. You just go ahead and here we go. There it is. And you can just change those variables on the fly, and it'll work pretty good. We are getting into a little bit of an internet problem, but you get the idea. So, once you put these in now, if you're using Fusion, Kev, are you using Fusion 360?
Yeah, that's what I use. And for the same reason, it started out free, and you get 10 designs or something, and then they start charging you. But yeah.
Right. So anyway, yeah, so you could see that I'll just move it along. Oh, there we go. So they go ahead and change the diameter of, let's say, the bolt or the hole size or like the whole thing, basically. And then you could just change it on the fly. So here they are. But you have to set this stuff up ahead of time.
Right.
Okay.
I'd also like to say that, like, just for doing basic stuff and getting a part out that holds your wires or holds your bracket, like, you don't have to get super complicated. Like, this is like advanced level. Like, to make the basic stuff, it's not that hard. Don't be intimidated by it. Try it out. Usually it's free. And, You know, when you make a mistake, it's easy to crumple up the paper and start over again.
Yeah, totally. Okay. All right, cool. So that was it for that. Let's go now to let's go to actually putting parts in a vehicle. I think it's Alex's turn now. So Alex from Maverick, very cool stuff. What an incredible situation. He's providing a lot of good solutions for the EV world, and he's got these drivetrains. Alex, you want to tell us a little bit about what you're doing there, and then we can get into like your iterations, how you use it.
First of all, I just talked to Tom that I 3D printed my Maverick e-beam just like this.
Oh, nice. Do you have a photo of that 3D printed?
Yeah, it's just a link from my Instagram, and I send it.
Oh, okay. Yeah, I have it. I got it. No problem. Oh, that is so cool.
We've looked into for 3D printing is these motors are too heavy to pick up and bring where you need to, and they're dangerous and they're expensive. So, 3D printed it first, and yeah, it's not going to get you down the road, but it's going to make sure everything fits when you need it to.
Yeah, I 3D printed my e-beam and took it to my showroom in Texas.
That is super cool. So what an incredible thing that you can just 3D print something, and then use it to fit, to make a decision about how something's going to fit. Now, what's going on in this photo here?
Yeah, and I can show you. I can show you about this. Oh, hold on.
Okay. I've got his Instagram right here, and I'm showing that he's got the whole chassis, and this is like an off-road vehicle. Now, that looks
just like.
Go ahead.
Just like this.
Okay. Now it looks like a gas engine. Where's the electric motor going to fit? Down here? Is this a hybrid?
Not boy. We just put our Maverick 25 in the free and have something trying to. This is a e-beam Maverick e-beam unit. This is a Maverick e-beam unit, and we're trying to figure out for FJ40 because I'm a Land Cruiser. I'm the Land Cruiser fans at the same, literally.
Wow, this is a treat. So, are you going to put it in the drive shaft line where it was? Can you show like a top view?
Yeah. I'm figuring out.
Oh yeah, so it's kind of like a drive shaft interruption. That's wild. Oh yeah, look at that. Okay, there we go. There's a top view. Oh, so I see you have the E-axle in the back.
Yes, it's a here and here. It's a Maverick e-beam, and we're going to try to figure out the suspension. Use the 4-link to off-road. It's an electric off-road Land Cruiser, right?
Wow, that's going to be popular. People like that stuff,
Yeah, I love this too.
Yeah, man. Pretty wild. Thomas, take a look. This is going to be one of the motors that you guys maybe use for your Kubota. He's got that motor right there in the middle. Can you zoom in on that, Alex? Oh, there we go. So he's got axles that have electric motors in them, but then he also has that one in the middle, and that's that is like, it's kind of like a Tesla motor turned longitudinal. Talik, what do you got?
I was just having Johnny come look at Alex's setup. So you said this is for an FJ, right?
Yes, it's for FJ40.
That's pretty cool. Yeah, right in the middle there. Yeah. That looks like a Torque Mountain's Jeep setup almost too.
Oh yes, it's almost the same. Yeah.
Nice.
Oh, cool. I see. And you have a 4-link. I see. You're making brackets for that.
Yeah, I will manufacture it in China, and maybe I will ship to Texas to promote the Maverick 25.
Yeah, nice. That is awesome. Pretty cool. Alex, this is a great work you're doing and showing what is possible with just doing the CAD work to figure out where your placement is going to be.
Yeah,
Very
thank
cool.
you. And this is FJ43, and it just put my Maverick 25 model in it, and also the Maverick EV, and also I can put the Maverick 12 rear drive unit to drive the rear or front differential, and I can use my own VCU to control both of the motors. Yeah, and also I have a new product to show you guys. Is a Maverick CCU, which is the 13 kilowatts OBC.
Oh, what's OBC mean?
Onboard charge unit.
Oh, onboard charging unit.
Yeah, I can show you now.
Oh, so that's pretty cool. So you have a charger now.
Yeah, I will show you. It's a little heavy.
Oh my God, he's got it right there. Hold on, let me pin that.
It's a 13 kilowatts OBC, and it's a 2.5 DC-DC, and also it's a junction to the motor. So it's contain the junction box in it. Actually, literally, it's a 3-in-1. The OBC and the DC-DC and the junction box 3-in-1.
Wow. Tyler and Nick, is this something you guys could use in the racing situation? What do you think?
I would say that's actually pretty slick. I don't know if we can use it for racing because we don't want a charger on board, but that combining the junction box and the inverter would help us quite a bit.
Okay. So is the junction box kind of like a contactor box? It's just a place to put the high voltage?
Yes, something like that.
Okay. That's interesting. And 13 kW, that's a pretty good charge.
Yeah, that's almost half time to charge the battery.
And that's from AC to DC, right?
Yes, it's AC to DC.
Nice. Now, that's pretty cool. How big? And it looks like you can carry that. Justin and Jonathan, you guys gonna put that on your car? Maybe. What kind of charger are you guys using?
A similar approach, actually. I got a from TC Charger though. I got a combo onboard charger and DC-DC. It's like 6.6 kilowatts, and the DC-DC is like 1.5. But yeah, similar concept. I wanted, because I don't have a lot of space in the Spitfire, so I wanted to consolidate as much as possible. So yeah, it's a great idea.
And I got to tell you, if the faster you charge, you know, I'm driving a Model Y now. The supercharger is like a game changer. But when you go to like those home chargers or a public charger, if you're under 6 kW, man, it's just not even worth it. You know, like it's just such trash. You need like 10, 13 kilowatts. You need like power, man.
Well, especially if you're dealing with a low, you know, the lower the efficiency of the vehicle, the more you need a higher powered charger to get meaningful miles. So
that's also true. Yeah, if you had a good vehicle. But you know what, the classics, everybody likes the boxy looking classics. So what are you gonna do, man? People are in love with these old vehicles. They want the modern drivetrain with the old vehicle style. You know, so it's kind of like, well, anyway, so coming back to the CAD and the theme tonight, Alex, this is great stuff. I really appreciate it. Now, let me ask you a question. Do you give out the CAD, not the internals, because that's proprietary, but the outside dimensions so that someone could put it in their design? Have you thought about that?
Yes, I can share the views to everyone of Maverick 25 and Maverick EV, the step views or STL views. I can share that.
Oh, that would be great.
But,
You know, I don't know if people are aware of raise your hand if everybody knows McMaster-Carr.
Oh yeah.
Yeah, everyone, right.
I'm their number one customer.
Yeah, so you know, well then you're broke then because they're expensive. No, but what's fantastic, preaching to the choir here, and maybe Sifa, she's new, so maybe she should learn it. Is that what happens is you take, let's say, for instance, even if you needed like a nut or a bolt, something simple, and let's say you go to let's say the screws and bolts, and then you just pick one. It doesn't even matter what you pick. Like you could just pick something. But what's kind of cool is they will give you the actual CAD file. It's just loading. Let's see. Log in to view product detail. Oh, that's weird. I have to log in for this? Nah, get out of here. I never had to before. I think it was, oh, that's interesting. You have to log in now. I didn't know that. Okay, well, I have a login, but I'm not going to do it now. So anyway, yeah, they give you the CAD and then it fits in your model. And so if you're new to CAD modeling, like you don't have to struggle. You could just download the stuff you need and populate the model. All right, so probably
like let's say it was something more complicated, like a linear actuator or something else, or a bracket, or a, nut and bolt is not that interesting, but then it's really helpful. So I mean,
yes,
see how this linear actuator is going to fit in your design.
Yeah, 100%.
Can I show you something real quick? I have this
nice.
3D printed AC51.
Oh no way!
Motor. It took almost 3 days to print, and it's a little messy, but this is I actually ended up not going with this motor. I went with the Motenergy one, but it was good to see it, how it fit in the car.
You have to glue that together or what?
No, this was actually the upper limit of what my printer could do. 15 inches tall, and I couldn't even print the shaft out the top, but this is all I needed. This was some cheap Creality printer.
Okay.
Like basic stuff, but they got the job done. Again, there's some spaghetti there, but
right, but that's
a rough fitment,
model that you can hold on your lap, you can put on your shoulder, you can fly with it on an airplane if you had to. You're not going to bring that whole motor with you.
Yeah.
To where you need to go. So yes, for dimensionally fitting, that's great. So
definitely
a good use of 3D printing I found is I needed bus bars, and I didn't know if it was going to fit or not. And I was very beginner at the 3D modeling too. So before I went and sent it to Send Cut Send and had 100 of them made to find out that I'm off by a millimeter, I just 3D printed them and hooked them up to my batteries and went to see if they fit. And if they do, then I send it to Send Cut Send and had 100 of them made.
Yep.
Frank's got a question. Go ahead.
Yeah, I was just seeing that McMaster-Carr feature, and I was wondering if like Mauser has anything like that, because a lot of the times you're stuck trying to get wire connectors, plugs, and it may not exist, and maybe you can make it in CAD. And then has anyone had to do that?
Yeah. That's something actually I was going to show. I found some models from one of the popular electronics websites for some of the connectors for some Deutsch connectors. They've got CAD models for, which are really useful.
Okay, that's pretty
See
cool.
if they're going to fit or interfere.
If you could dig that up, that would be awesome. Speaking of downloading models, there's a lot of stuff out there, like even this, I don't remember where we got this from. I think we were on a call with Richard at the time, and we got this pretty detailed Model S motor. So this gives you all your mounting points and some details that go with it. You could even dissect it a little if you wanted to. I just pull it into Onshape right here. So that's pretty
cool. Things like this is where the coolant goes in and out. Is this going to interfere with the frame of your car? Well, you made one, you'd find out.
Right, exactly. Pretty cool. All right. So in the interest of time, also, let me see, Sifa's there. I could see her. Did you know about the McMaster-Carr situation?
Do you wait for like CAD, the parts to CAD?
Yeah.
No, I was not aware of that.
Okay, this is the gem. So check this out. So let's say this was the particular screw that you needed. Okay, random idea, but you would just go over to pick your CAD. You see right here, and then usually just take the solid modeling one, like SolidWorks, download it, and then upload it into, let's say, upload it into, let's say, the CAD program. Oh, Alex, thank you so much. That would be great. And we would love to see the CAD models at some point to help with the students, students, we're all students, putting it in together. Pretty cool. So anyway, am I saying it right? Sifa, right?
Yeah, you are.
Okay, perfect. So Sifa, so what you do is you have your CAD model here, and then let's say you go into here and you pull up a document and you go to create new document. Oh, and let's just say, we'll just call it, test, test 2 or whatever. I don't know, because I probably have a test 1 somewhere. And then just go into import right there, and then pull up the screw that you just downloaded. It'll import it for you. And then it should pop up. It's just in progress right now. It takes a minute, and you just click on it. It's loading, and then there it is. So now you have like all your dimensions, and you can put it in your CAD model. I mean, obviously, this is ridiculous. It's just like a screw. But like Kevin was saying, McMaster-Carr is like wide open. This is like a lot of stuff. These are all mechanical parts. So anything you can think of, I don't think they give you the CAD model for everything. Like you can buy brooms on here to sweep your shop. They're not going to give you the CAD model for that. But if it's something that you buy that gets inserted into an assembly, it's going to be on here. So, and I guarantee you
there.
What's that?
Try that gear, that sprocket right there.
Oh yeah, sprockets.
Yeah. They also
they'll totally give you that.
Super nice.
Yeah, this is like super on product detail. Boom, there it is. Download, and then click, and then just go back over to your CAD, import, share this tab, import, and then just pull up the latest file, roller chain. Boom, we're actually doing this pretty quick, which is nice. And then it'll pull up its own little tab. You click on the tab, it's still loading, and then pow. Let me just get rid of these. These are kind of in the way. Okay, here we go. Look at that, Sifa. Pretty sweet, right?
Print it and then see if it's going to fit in your assembly and interfere with anything.
Right. So it's not like, I mean, it's kind of like cheating, but they want you to, because if it fits, you're probably going to buy it from them. That's why they're giving you the CAD. They're not giving it to you because they like you.
Sell more stuff.
Yeah, exactly. Same with even what Maverick, Alex from Maverick was saying, he'll give you the file. So if someone wants to see if his charger fits in there, go for it, All right. So
another thing we were talking about this summer is like, wouldn't it be great if there was a service where you can buy or rent a 3D printed version of the Model S motor? So they'll ship it to you. You go try out what you need to. This is not the kind of thing you need for a lifetime, but I need it for a couple weeks to go try it out and then send it back, or like a lending library of printed parts, like Tesla batteries, things like that, where you need to check their fit.
Yep, totally. And that's pretty cool. Who was that? That was Justin that had the 3D printed AC50.
Yeah.
That's awesome. Justin from Homebrew. He's got an Instagram. You guys got to follow him. He's doing cool stuff.
They're going to go and make it into a drink dispenser or something.
Yeah, I got to put it to good use.
Funny. So, okay, so cool. So moving right along, I think I want to go over to Tyler Joy and Arcblast, and then we'll probably go over to Zach and get an update from him. And we'll just keep on rolling. So Tyler and Nick, you guys want to give us a little presentation of your CAD model? Oh, and Jonathan Knight. I can't wait I want to get to his scanned vehicle. To me, that's like insane. Oh, wow. Look at this. This is like Such
You
a
guys,
treat,
can you guys hear me now?
dude. Yeah.
All right. Sorry, my mic wasn't working earlier. Before I forget, McMaster has all their tools with CAD models, which is incredibly useful for tool clearance. So,
Oh wait, what do you mean tools? Like,
here, I'll just pull it up real quick.
okay,
You guys see this?
we are looking at the yellow and blue scan.
Uh-oh.
We're on
Sharing the wrong
SolidWorks,
screen.
which is so cool. I can't wait to get back to that. That's incredible. I can't wait to see that. Okay, here we go.
Yeah, we got it now, Tyler.
Now, what tools are you talking about?
Yes, like ratchets,
Oh, really?
wrenches, things like that. Yep. So going all the way back to the charge adapter plate, the mount, make sure you have tool clearance when you're redesigning that. And the best way to do it is drop a tool in CAD. So,
Really? That is interesting.
So if you drop a tool, you'll know whether it'll make it to the floor or get hung up somewhere.
yep.
Nice.
Anyway,
dude, this is awesome. I like that. Oh, I saw a little homebrew like floating up there. That was cool. All right.
Yeah, I guess.
Yeah, I'm strapped in. I can't wait to take us for a ride through this CAD model. This is insane looking.
Man, there is a lot in here. It's hard to know where to start. So this is basically just just a really basic model of our car, right? This is mostly here for trying to figure out little aero bits, like do our battery packs fit? Can we fit a motor in the frame? Things like that. Man, I really don't know where to go from. Is there anything you guys want to know?
Okay, just go with the batteries. That's the main thing. I pulled it on a different screen. That's why it looks like I'm looking over here because I got to see this big. This is like this is great. Look at this thing.
Maybe battery and drivetrain and that whole area, Tyler.
Sure. Yeah, let's go with batteries because I think that's a functional thing that you could probably slide in and out and show us how it fits and everything. Wow.
Yeah, so a lot of these models like are purchased, downloaded. Like when you're trying to move quick, everything you can find online is gold. So, all right, where to start here? So this guy, this is like a representation of the frame, and that's what I'm basing most of our fitment off of. There are some 3D scans I have, like for getting down to like the millimeter type of clearance, or like I had an issue where this motor was too low and we were misaligned with the differential. That was causing some vibration, which I can get into that in a little bit. We can do a bottom view here.
Let me interrupt you for just a second. Can we just look at this thing for a second? This is not normal. We are looking at a mid motor. Am I right? This is mid mounted.
Yep.
Behind the driver, but before the front axle. This is like straight out of like a night. He's got the Ferrari playbook from like 1980.
Yeah, I mean, there's a lot of benefit for what we're doing, right? We don't have a transmission. We don't have a long drive shaft. Our weight distribution is worse, but it's still 60-40. So we're like still in a good performance range. Yeah. Here, let me show the rear diff here.
60-40 rear, right?
Yeah. So I get 40-60 rear, so 60 in the rear.
Gotcha.
Which for regen actually helps us quite a bit. So we get a little more traction on deceleration. But yeah, so this motor just lives right underneath the battery, right at the back of the cab in the bed. I don't have the model set up quite right for it right now, but that bed's actually going to pivot up around this point here. So then the battery pack comes out the side of the vehicle.
Wow. This is so cool.
So
let me ask you, go ahead. Yeah, let me ask you like an honest question. Like, how much of this planning actually ends up working in the real life? And you have to go back, which is fine, but you have to do like a lot of iterations probably when you get to do the real thing, right?
Yep. Yeah, there's always something wrong. Like I do mechanical engineering for a living, and even at work, you're doing revisions, you're making stuff, you're figuring out problems, and then you're doing another revision, right? It's really hard to know every single detail in CAD, especially like when you before 3D scanning, right? And even with 3D scanning, you have to deal with accuracy, file size. Like if I were to actually show you the full scan I have, my computer might crash. So
wild. Okay,
yeah, so
cool.
like, this is actually the 5th revision of these motor mounts I've had. So
nice.
You want to jump into the battery a bit, Tyler?
yeah. So I don't know if I mentioned this before, but we're hoping to swap our battery packs in about 3 minutes, which gives us about 5 minutes in the pit and back out. So this whole battery pack, which I'll bring up the model in a second here, is actually intended to slide out the side of the vehicle, and it looks like I have it fully constrained. So underneath here, I've actually got a bunch of conveyance rollers that are from McMaster.
Oh, no way.
So you unbolt this thing. It's on die springs, also from McMaster. Battery pack comes off about 1 millimeter and slides out the side onto a cart.
What's a die spring?
They're just really beefy springs, usually used in like injection molding.
Okay.
Yep.
Dude. Awesome. So the carriage that holds the motor is also the roller frame.
Kind of. I don't have them tied together. They're actually joined through the frame. But the support system for removing it is part of the motor mount.
I like it. Let's
see here. Pull up the battery for you guys.
Oh yeah, there you go. And is that a sheet metal part that you made?
Yeah, so you're talking this piece here.
Mm-hmm.
Yep. So this is it's a square tube and sheet metal weldment. Some aluminum tubes running through here for cooling.
Nice.
Yep. Which I actually don't know if I've shown you guys that before here.
Dude, this is detailed. This is great.
Yep. But this all ties into what we've been talking. Like requires all the basics, right? You have to be able to make a CAD model to be easily revised. Pulling all these CAD models from the internet so you don't spend hours finding every detail. Like this is what you end up getting to if you continue getting experience, right? And I'm not even all that good at this. Like there's people in the mechanical design world who can make these models in like a day or two, like just know exactly how to do it perfectly.
So nice. This is awesome. Cool. Oh, the cart. You even made the cart.
Yep. I actually just finished this revision last night. So
where'd you get the person?
I got this off of GrabCAD, which is another like useful place to get just random CAD models. So
yeah, GrabCAD's great. Where's Siva? She needs to take note of that. GrabCAD.
Yeah. And I saw Justin also posted Thingiverse, which is another great resource.
Oh yeah, that's true. Thingiverse. Hilarious.
Yep.
Real quick, how many guys are allowed to work in the pit? Is there a limit?
Good question.
Say again?
How many guys are in the pit?
I actually don't think we have a limit. I'm expecting 2 people right now.
Okay.
Thomas, they're in this racing series called 24-hour lemons, and it's like their limited budget. But when it comes to, and it's all gas stuff, but they're trying to enter with an EV, and it's very difficult because speed-wise, no problem, torque, no problem, but how long can you last doing laps for 24 hours? So they're doing battery swaps.
That's cool. My buddy did the lemons like tour, like I don't know what it's actually called,
rally?
but is that what it is? You just go from. It's a pretty long trip, but it's several days.
Yep, that's the one. Lemons Rally.
That's cool. Yeah, he told me about that. That's really cool.
And how did you do the scan?
Yeah, so I used well, okay, so this bigger scan, I actually have a buddy who uses a 3D scanner for crime scene investigation, of all things. So this is actually pretty low res. I think it's like 5mm. But let's see if I can get this to open for you guys.
Yeah, you just need to see the body lay in there, right?
Uh-oh, it's frozen.
This is wild. What a cool thing.
I use a scanner called Einstar.
Okay.
I'll pull it up here. This guy, not too bad.
Nope.
Still a little pricey, but for like your average hobbyist, this is achievable, right?
Is it
This
better
can go-
than the iPhone?
Oh, this is magnitudes better. I think this goes down sub-millimeter. It's a tight enough tolerance that I can, yeah, here we go. It's a tight enough tolerance I can get in here and actually design drivetrain layouts and scan like the frame. And so I know it's going to fit first time, essentially.
Sweet.
Yeah.
Wow, that's actually pretty cool. Which part is scanned? Is the blue scanned?
The part that is crashing SolidWorks. Hold on.
Oh, that's okay. Turn some other stuff off.
There we go. Yeah, so this guy is a scan.
All right. I'm just going to put this on my bigger screen so I can see it. Wow, this is so cool. That's cool. You want to zoom out? Show us a little bit?
Yeah.
Okay.
Need hide the chassis here as well.
Yeah, is it still crashing, right?
It's not crashing, but it's definitely not happy.
Okay. Well, yeah, maybe you could fiddle around with that, and we could come back, just in the interest of time, because we're trying to keep these to an hour, but we're over an hour now. But that's okay. Maybe mess around with it. It's super impressive what you guys have done. I really appreciate you sharing that. Some people wouldn't share it. I really think that you're helping a lot of people, especially people on this call. I know Thomas is going to go crazy and like convert his Kubota, and we got Siva. She's young and she's gonna be like the next generation. Very cool. And Richard is he is so good at digital, but he's going to be real good at CAD soon. I know it. So, okay, let's go to Jonathan Knight for another scan and component update in quick iterations using send, cut, send. All right, what do you got for us? Go ahead and present.
Yeah, so I was going to actually bring up what I've been doing the last 2 weeks, which is working on the battery boxes. I'm learning so much tonight because there's so much knowledge here, which is awesome. And I'm definitely going to take advantage of that McMaster stuff because I need some nuts and bolts and things like that to get into my model. But basically, I've been thinking about what my battery box should look like or how it should be built for a long time, but I hadn't really, done it practically. I got my battery modules from EV West, and they had the 3D models for the modules, right? So
nice.
They were available on the EV West website. So I downloaded that. And
are these LG chems?
Yeah, exactly. And I knew I was going to fit 6 of these units in each of my battery boxes and have two of the boxes. So I just started by lining them up and started to think about what goes into the battery box. And so I just started modeling all of the little components and laying them out.
I like how you layer this out for us.
Yeah, so I modeled up the bus bars, if you guys can see, I got these ones already made, which are the copper bus bars, and I modeled those and put them in, and then I got I modeled some contactors.
Those look great.
Yeah, just taking measurements and then, you know, just sort of building them out. Didn't take that long.
Yeah, that's really cool. And
I
are
got
those are those
will not only cut, but they'll also bend now, right? Those are
They will bend. So I'm hopefully the more complicated ones that I'm sort of making now, I haven't gotten these cut by Cut Send yet. Hopefully they'll be able to do that. If they don't, I'll have to bend them myself, but they're a little bit more complicated.
nice.
How did you have that? There was some kind of funky J bend on the one on the far left side there.
Yeah, because it has to come out of, there's like a little pocket in the battery module that it has to come out of. And then it has to sort of bend around in order to reach the right height for the contactor.
Oh, yeah.
So I worked that out. And I was thinking about, you know, practical things like I've got all these kind of exposed contacts on both sides of the battery. And then I'm going to have metal walls of my box. So I kind of thought about some like fiberglass insulation sheets to place in there just to kind of isolate things a little bit. And also do double duty to mount the BMS units too.
Yeah, that's a good idea.
Sorry?
You could 3D print something. It'll be
absolutely.
insulated.
Absolutely. So basically, yeah, I was able to kind of fit everything in to this space. And then there's a couple of other little bits, like there's these bars that I want to lock down the battery modules so they don't move around.
Oh, that looks familiar,
cool.
Kevin.
Sorry?
Oh, sorry. I was just asking if you had any cooling, Jonathan.
Oh.
I'm not going to have any cooling in my battery boxes. For one thing, these modules are not that easy to cool. They don't have any surfaces that aren't covered in plastic. And another thing is I'm not going to be racing my car, so I'm probably not going to have that much heat gain. So then the next thing I started to work with is, so what is my battery box going to be made out of? So I just modeled these 3/4 inch steel bars, angle bars, and then, you know, just sort of built a box.
Okay, that's pretty cool.
Yeah, and then just started thinking about what's going to go into the box. So, you know, a sheet of what I'm thinking is going to be just a sheet of aluminum across the bottom, which will sit on that shelf and then be bolted in.
Yeah, that's really cool. Are you going to get Cut Send to make these parts?
That's what I'm thinking. That's what I'm thinking. And then the front, back, and top ones will sit on the outside and get bolted on from the outside, because I'll have to be able to remove those in order to get access to do any maintenance on the interior. And then one of the cool things I was able to get downloaded was it's turned off. So these are like some Surlock high voltage connectors, and then this is a Deutsch connector for the low voltage components.
Oh wow, this is really good.
Yeah, so it's kind of cool because then you start to figure out where all these things can go, and you know, they connect to the bus bars.
Yeah, man, this is great. Now, this thing, have you considered how heavy this is? Is this your entire pack?
So this is the whole pack. Yeah, I'm a little bit concerned about it, but I think with the aluminum plates, it probably won't be too bad. The steel bars are not terribly heavy. But the next thing I was looking at is placement. So I'm gonna have two of these. So I have like another copy of it here.
Whoa.
And like we were saying about doing the scanning, I use my phone. I don't have an expensive scanner, but I use my phone to scan the bottom of the car here.
Dude.
And I'll
what
turn
car
these
is
off
this
for a
again? A
second
Honda?
so you can see that.
What's this car again?
It is a 75 Honda Civic.
Oh my God, and you're putting all this battery in there. There's so much battery.
Yeah. So so you can see this is
a
sort
ton
of the
battery in
underside
this car.
of the rear of the car. And
I'm going to call Soshira Honda, and I'm going to tell him what you've done. And he's going to roll over in his grave, man. This is like a lot of power for this little car.
Absolutely. So this area here is where the gas tank came out of. So it's kind of a perfect spot. And then this is underneath the rear trunk, which it had a spare tire. So I'm sacrificing the spare tire.
All right.
And I was really happy to see that when I get my boxes in there, they fit really nicely.
Dude, that's great. What about suspension? Is it out of the way?
Yeah, so this is, I mean, this model is extremely rough from the scan, but you can see this is the rear axle there, and it's basically on leaf springs.
Drive. It's front-wheel drive, so it's just like a trailing axle. It's not really doing it.
It's almost like, it's just a solid axle. It's got leaf springs. It's possible with the weight of the batteries when I get them in there that I might have to beef up those leaf springs. We'll see how much it sags. I've considered that, but that's not a huge deal.
This is so interesting. Wow.
So the
the
next step that I am I'm doing with this is figuring out how to mount them.
I was just gonna say your brackets. You get. I'm sure it goes without saying. You got to spread the load. You can't just bolt it to like a piece of sheet metal.
Exactly.
You're gonna have to back it up. What they did, if you might want to take a look, and Kevin can help you with this. And I have some photos. You might want to look at the battery mounting option for the bus that we did last summer. And what you'll find is that they put a kind of like a bar on the top of the sheet metal, and then countersunk really heavy duty stainless steel bolts that went down and grabbed the box to go on the bottom of the sheet metal, just like you're doing. So the load is spread out on that big piece of sheet metal where you would have held, it would have been the gas tank or a spare tire or whatever.
No, that's a good idea. What I've done is I've just did a very basic model, but basically tracing where the load-bearing rails of the frame are. So if I turn off so you can see I when I was scanning this, I just went under there with a can of spray paint and sprayed this blue paint along the rails, just so that I was sure I would be able to see them in the scan.
Yeah.
And so then I basically traced those using just some basic cubes and shapes. And then I went back to the actual car and measured with the measuring tape and did it on paper, just to make sure that all my distances between all of these beams were correct.
Dude, that's a really good idea.
That way I can start to model out some kind of brackets that will connect to those. I mean, the idea is to connect to those rails.
Yeah. I have some photos. I don't want to interrupt you presenting, but if you stop presenting for a sec,
sure.
I'll show my photos that I have of the bus project that relate to what you're talking about. So here you go. As you can see, this is like where the gas tank would have been. And you see these strips of metal right well, there looks like aluminum. And so you could see that, you know, when you put this box in, it kind of slides in. See, we kind of rolled it in, and that was empty when it was empty.
Yeah,
rolled it in. Right now, it's a tight fit. We were like, oh my god! But just like you said, there are these folded pieces of sheet metal that are considered the load bearing here and here and here. You can even add some if you wanted to, and then we cut holes. And you might want to use a stepper bit like we did right here, because it doesn't grab it and then pull you. It goes thud, 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 thud. It's really nice. I don't know if you've used one of those.
Yeah.
Okay. So
that's awesome.
Yeah. And so then they had these, let's see. So this is kind of like, you know, what you're seeing here is, you know, we bolted it from the top.
Right.
And it's spread out.
Yeah. It's got lots of strength. It's not going to pull through the sheet metal.
Right. Yeah. Well, you'd hope not. And then countersink helps. So anyway, yeah, that's kind of like, I hope that helps.
Definitely.
Yeah. Dude, this is so cool what you did. I really appreciate that. You know,
yeah, can I show one other thing real quick?
Yes, please. Yeah, do it. And then I think, who else are we missing tonight that we were going to cover? Did we get to everybody?
I just wanted to share that taking from those models and the measurements that I came up with, just today I started welding together these battery box frames.
Nice. Oh, well done. There you go. Ooh, that's a good looking weld. There you go.
Thank you.
Yeah. Is that a MIG welder with gas?
Yeah.
Nice. Good job.
So, and then fitting those frames, the pieces of the frames, just to see where they fit in the actual, against those rails inside.
There you go.
So I'm confident now it's all going to fit, which is really cool.
Ah, this is great, man. And your car is going to be a sleeper? Like, is it going to look like an old car?
I would assume so. I'm going to paint it the original color. I kind of regret stripping it because it kind of looked pretty cool when I got it, but I did, so I'm going to get it repainted.
Oh, dude, come on, sleeper car, and then like just roll up at the stoplight, just liquefy your tires. You know. Anyway, I think we got to everyone that was going to present CAD miles. Is that right? Okay. That was great. I don't want to make the episode too long.
I think we lost Ron.
Oh no.
Please hang out.
There you go. Ron, you're
okay. All right, I'm back. So basically what I'm planning on doing is ending the recording here, and anyone who wants to hang out and we'll talk about Thomas's Kubota project, or shoot the shit for a minute. Anyway, anything else anyone wants to add before we get out of here? Okay. All right. So yeah. Okay, that was great. Man, we learned a lot. I like that scanner that Tyler had. Tyler, can you drop the scanner in the chat? I'll kind of want to look at that.
Yeah, I'll drop in there. I'm also going to drop in a CAD mouse that I really enjoy. So here's that.
Nice. Oh, and then I have one last thing. I can just, somebody put in, somebody went ahead and gave us the model for this. I forget who dropped that in the chat, but here you go. You got a situation where you have your contactor, and I just pulled it up on Onshape really quickly.
Oh yeah.
Yeah.
I should also mention places like Mouser and DigiKey. If you find the manufacturer of that part, usually you can go to their website or just email them and they'll send you a CAD model.
Nice.
Well, it looks a little better than mine, but
well, you can have this one. What was this? Was this a Tyco. Is that right?
Yeah, it's a Tyco.
Okay, super cool. All right, well, yeah, so we're gonna end the recording there. That was super cool. I feel really lucky to be a part of this group. I'm glad everybody was here, and yeah, tune in next week. And for now, we're just gonna probably hang out. Talik, anything you want to add? Oh, you're muted.
Not at the moment. I mean, Johnny's doing some welding.
Oh yeah,
making new control arms.
Nice.
Yeah, the Luxie's getting like an update every week. It seems it's like never satisfied.
Oh, that's cool. The only other thing I guess I could show real quick is Johnny's DeDion axle. I had that queued up, ready to go. I think it's I gotta reload it. That was a really cool thing. He open sourced the file for that. Oh yeah, so this is what's underneath his Luxie pickup truck, which is kind of like, it has a DeDion axle, which is kind of like a live axle that goes around the motor, and kind of the motor stays in place. And you can see, he's done a ton of videos about his pickup truck and how it works and all the upgrades he's doing, like a hitch, and it's Tesla powered, but it's got an i3 battery pack. So there's just a lot of cool stuff that Johnny's doing, and you can catch up with him on. He's also rebuilding the Tesla motors because there's an inherent water problem with them. So pretty cool stuff. And then this one here, this is the axle, and then your leaf mounts would go right here. All right, I think that covers it. This was an action-packed episode. Pretty amazing.
Yeah, last minute subject worked out really well. So
yeah.
Also,
if anybody's in Southern California on the 13th of April, there's a big EV fest put on by Tesla Club SoCal and SoCal EVs, and as many EV conversions that can make it to that event to be awesome. We're trying, especially if there's any electric converted Mustangs. Mach E-Blog is celebrating the anniversary of the Mustang at this event as well. So April 13th, Long Beach College, Community College, I believe, SoCal EVs, Tesla Club SoCal. Check it out. It's going to be a huge event. We already have over 300 cars between modded Teslas and some other cars coming up to this. So yeah.
Cool. And Kevin, real quick, what's going on with the bus? Does it charge yet or what, man?
Yeah. It's charging on level 1 right now, just because I have the is my camera on right now?
Yeah.
I'm at 2% battery. I'm afraid to do anything here, but
oh yeah,
you'll see me.
Yeah, we see you for now.
Okay. Yeah, bus is charging. You see the new setup there? Can you see that in the picture? I lost my own video.
Sort of.
So.
Oh, anyway. No, can't really see it over your shoulder. Just aim it right at the engine bay.
Yeah.
That's better. Oh yeah, there you go. Nice. Super cool.
Yeah, and I got the torque in here and charging too. So
oh, look at that. That's a whole other vehicle. Yeah. That's pretty cool. And I don't know if everybody knows, where did that torque vehicle originally come from?
Yeah, that was a see, I'm having my charging problem here. Yeah, it's that is from the founders of Aptera. Had done this car when they thought their company was going to be for crazy carbon fiber sports car type things instead of a economy solar car. Nice. So they made probably only about 10 of these. As far as I know, this is probably the only one left on the road, and I got it with a bunch of bad batteries, and I've been rehabbing it. Yeah, Frank's helped me with building battery boxes and things like that. It's perhaps a subject for another day, but
yeah, there you go. Yep,
I was able to do some work on it. You see Peppa Pig on the floor. That's my Elcon charger reprogrammer. So it's a mess.
Oh, okay. Yeah, the torque vehicle should just be its own episode. I think that's a great idea.
And why you should never take on other people's EV projects when they've abandoned them.
Well, you got to learn somehow. So,
ouch.
All right. All right. Interest of time, let's end it right here. Thank you so much, everyone. We'll be hanging out for a little bit after the recording, and see you guys again.